Hello guys, hope you are doing great. In this video lecture I'll be talking about a name reaction series that is in my channel playlist, organic name reactions. So far we have covered different types of name reactions, but today we are going to discuss Mannich reaction. So Mannich reaction is an organic reaction which is used to synthesize amines, particularly tertiary amines containing carbonyl compounds. So if you look at the Mannich reaction, you would require three things. One is aldehyde or ketone. It could be aliphatic or aromatic. Second, formaldehyde, again another aldehyde but a primary aldehyde. So the first member of aldehyde is formaldehyde. And third thing that you would require for Mannich reaction is primary or secondary amine plus HCl. So these are the four starting materials you would need for Mannich reaction to get this product. Now if you look at the product, you are making carbon-carbon bond as well as carbon-nitrogen bond. Okay, so you are combining all these fragments together to join this functionality. Now if you look at this functionality, this is alpha, this is beta. So beta amine containing carbonyl compounds. This is how you can prepare by Mannich reactions. Again, I'm repeating, in Mannich reaction you would need four things, four starting materials. One, in any aldehyde, any ketone. Second, formaldehyde. Third, primary or secondary amine. Fourth, HCl. Now you combine all these together to get the beta substituted amine containing carbonyl compounds. This is called Mannich reaction. So it is used for the synthesis of tertiary amines containing carbonyl compounds at the beta position. Okay, by this time you would be familiar what kind of starting materials we need for Mannich reactions and what will be the product and what will be the starting material. Let's further discuss about Mannich reaction. Later on in this video we will be discussing in detail the mechanism of Mannich reaction, examples of Mannich reaction, applications of Mannich reaction, and steps involved in the mechanism of Mannich reaction and how we can apply Mannich reaction in retrosynthesis. Let's move on to the next slide. Again, I'm introducing Mannich reaction in a slightly different manner. What you need is an enolizable carbonyl compound. Enolizable carbonyl compound means that carbonyl which contains alpha hydrogens that can be deprotonated to generate enolate, and that's why we are calling it enolizable carbonyl compound. Next, you would need non-enolizable carbonyl compound, and that is formaldehyde. And the third thing that you would need for Mannich reaction is primary or secondary amine. So if you are unfamiliar with classification of amines, I have made video about classification of functional groups and various types of functional group, where I have discussed almost all the organic chemistry functional groups in detail, including their classification. You can watch that video in order to understand how we can identify which is primary amine, which is secondary amine. So these are the three things that you need plus HCl to generate beta amino carbonyl compounds. That is called Mannich base. It's also called Mannich base because it acts as a base for further synthetic schemes if required. Summarizing the Mannich reaction, you would need enolizable carbonyl compound. Number 2, non-enolizable carbonyl compound. Number 3, primary or secondary amine. Okay, let me define primary amine. That amine which contains two hydrogens attached with nitrogen. That is called primary amine. If there is one hydrogen attached with nitrogen, that is called secondary amine. If there are no hydrogens attached with nitrogen, that is called tertiary amine. So you combine aldehyde or ketone with formaldehyde and either primary or secondary amine to generate beta amino carbonyl compound. Why we are calling this beta amino carbonyl compound? Because here if you see, this is alpha carbon and this is beta carbon. At beta carbon we have amino group, and these could be anything. It could be methyl ethyl propyl, or it could be cyclohexyl, or it could be benzene. Okay, let's move on to discuss how these three fragments are joined together to give us the single product. So it's a multi-component type reaction. So we have different components, we have different starting materials, we have different substrates, and we combine all these reagents, all these substrates to give us one product. Okay, these are the steps we will be discussing later on in the next slide. What steps are involved in the mechanism of Mannich reaction. So number one step is called formation of iminium ion. This is a theoretical explanation of mechanism. In the next slide I'm gonna explain with more curly arrows where I will explain each step. But before explaining those curly arrows, I'm gonna tell you theoretically so that you can take note down what steps are involved in Mannich reaction. So step 1, that is formation of iminium ion. Step 2, formation of enol form of the compound containing carbonyl group. Step 3 is formation of Mannich base. That is the last step. So what happens in step 1? Iminium ion is formed by the reaction between primary or secondary amine that we call a Schiff base, or ammonia and formaldehyde. The reaction will be discussed in the next slide. And the step 2 is carbonyl compound forms enol. En means alkene, a double bond. Ol means OH group, form of by its tautomerization. Then enol form of the compound containing carbonyl group takes the reaction further. This reaction will be discussed in the next slide. So this step we will explain in the next slide. Step 3 is in this step enol form of the carbonyl compound takes on iminium ion, which forms amino carbonyl compound or Mannich base. Okay, these are the steps which are involved in Mannich reaction. Let's explain these steps in more detail with this curly arrows. Okay, this is your formaldehyde, which is non-enolizable carbonyl compound. What happens is it's protonated because this oxygen is more electronegative. It picks this proton and becomes hydronium ion, oxonium ion, and then this carbon becomes more electrophilic compared to the one. And next, the purpose of protonation is to make this carbonyl group more electrophilic in nature and make this oxygen more protonate this oxygen so that we can have a leaving group later on in the reaction mechanism. So there are a couple of purposes for protonation. Next step is a take of lone pair of this nitrogen. This is secondary amine, and this contains free lone pair of electron. Any atom which contains free lone pair of electron or negative charge, we call it a nucleophile, and it acts as a nucleophilic center, or it can take or it can donate the electrons to the electrophile. So the bond formation will take place between electrophilic carbon and a nucleophilic nitrogen. So the nitrogen attacks at the electrophilic carbon. As a result, the bond between carbon and oxygen collapses in the favor of oxygen. Now you will have a OH instead of double bond oxygen and carbon. That's the one. Now we have single bond here instead of double bond because of the shifting of these pi electrons towards oxygen. Now you are making a bond between this carbon and this nitrogen, that is this one. As we can see that nitrogen in this case has more formed 4 bonds. That's why it carries a positive charge. Now furthermore, it will lose one more proton. The nitrogen will lose proton, deprotonation, and it will become neutral. Now you have amino alcohol in this one. Now what happens next? This alcohol OH is acidic. It picks proton and it becomes OH2. Now it's a good leaving group after protonation. What happens next is the lone pair of this nitrogen reverts back and makes a carbon double bond, and this OH2 water is a good leaving group, leaves this one, and we have a amine functionality. This is what we discussed in the previous slide. Step 1, formation of iminium ion. Now this is called iminium ion because this contains a positive charge at the nitrogen, and this is imine because the carbon double bond nitrogen is called amine functionality. So these are the organic functional groups which I have discussed in my previous video about functional groups of organic chemistry, where described and defined how we can identify functional groups. Okay, this was the step 1. Now let's look at the step 2, formation of enol form of the compound containing carbonyl group. Now we have a compound which is ketone, or it could be aldehyde, but it must possess the enolizable carbon or enolizable proton. So this is called alpha carbon, and the alpha carbon contains couple of alpha protons that are available for deprotonation, and as a result we can get enolate or enolizable form. What happens, this is a enolate formation. It could be acid catalyzed or base catalyzed. In this case it's acid catalyzed. What happens, this oxygen picks this proton. Now in the next step, this proton shifts towards this carbon and makes a double bond, and the bond between carbon and oxygen is double bond. This pi electronic cloud moves in the favor of oxygen. Now you have a OH group and double bond. Now as you can see, this is double bond, that's why we are calling it en, and here is OH, that's why we are calling it ol, and combinedly we are calling this functional group as enol, or we can simply say enol. Why enol? Because it's a combination of double bond, that is en, alkene, and ol because of hydroxyl group or alcohol group. So that was our second step. If you remember, that's the one, formation of enol form of the compound containing carbonyl group. Now let's look at the last and third step, that is formation of Mannich base or the final product. Now you combine this enol and this iminium ion. What happens, this enol attacks on this electrophilic carbon, and this oxygen lone pair reverts back and forms a double bond between carbon and oxygen, and this pi bond, being nucleophilic, attacks on this carbon which is electrophilic, and the bond between carbon and nitrogen breaks down in the favor of nitrogen, and you get a bond formation, CC bond formation. And in the next step, this oxygen loses its proton. Now you get the Mannich base or the final product. So this was the mechanism of Mannich reaction, which involves 3 steps. So this was step 1, and this one is step 2, and this is step 3. Okay, let's if you have any questions regarding Mannich reaction mechanism, please drop down the comments below in this video, and I'll make the explanation more if required about Mannich reaction. Okay, let's discuss more examples of Mannich reaction. Now, as we now know that Mannich reaction requires 4 things. One is a carbonyl compound, either aldehyde or ketone, which is enolizable, 1 formaldehyde, and 3rd secondary amine and HCl. Now in example 1, if you look at this is acetaldehyde, this carbon is a enolizable formaldehyde, and this is secondary amine HCl. You get this. Now further you can use this product and react this with methyl iodide and in the presence of base to generate this Michael acceptor. So this is the utilization of Mannich reaction further in organic synthesis. Up to this is Mannich base, this one is Mannich base, this one is Mannich base, this is Mannich base, this is Mannich base. Okay, how we can use this Mannich base in organic synthesis to generate Michael acceptors. So these are Michael acceptors, or alpha beta unsaturated carbonyl compounds. Okay, next step is similar. We have aldehyde, we have formaldehyde, we have secondary amine. We will get a Mannich base, and that will react with methyl iodide, and elimination will take place, and we will get this product. So this is how we can utilize Mannich reaction to get our desired products. In example 3, again we have, instead of aldehyde, we have now ketone. Ketone reacts with formaldehyde, secondary amine HCl to give you this product, which reacts further with methyl iodide in the presence of base to get you this. And example 4, we have substituted ketone or bulky ketone. It doesn't matter as long as we have an enolizable proton or alpha protons that can react with this iminium ion, which we discussed in previous slide, how we prepare this final product using Mannich reaction from using the mechanism of this reaction. So this is your final product. These are the 4 examples which I'm showing you basically because you can easily identify what kind of starting materials you need and how you can predict the product of this reaction and which new bonds are formed and with a different color. So it can be easily seen that this red color is from formaldehyde, and this orange or yellow type color is from starting aldehyde, and this black color is from amine. So this is a beautiful identification that what parts are belonging to which starting material. So in this slide you can easily learn that how you can predict the product of this Mannich reaction when you are given different aldehydes, different ketones or different amines. And then this is also explaining how we can extend the Mannich reaction towards organic synthesis. So you delete this amine, you eliminate, this is elimination of amine, and you get a double bond at this red bond. This is applying B is equals to a base. Okay, B means base. Methyl iodide is electrophile, which is supporting the elimination. Okay, let's move on further towards Mannich reaction to discuss again the mechanism in a slightly different way. So you have a formaldehyde and you have a hydronium ion. So oxygen of this formaldehyde picks proton, and this becomes H2O, and this becomes protonated. Now this bond between carbon and double bond breaks in the favor of oxygen. Now this is how you can generate a electrophile of carbocation on this carbon. This is the secondary amine, N-ethyl diethylamine. Now the lone pair of this nitrogen attacks on this carbon. The reason why I am explaining the mechanism again, that sometimes students confuse themselves by looking the different ways of representing structures or looking the different bulky groups. They become afraid that what is this now, how we can explain this with the bulky group. So you don't need to worry about other parts which are attached with the structure. All you need to focus on the centers, electrophilic center and nucleophilic center, and you can push these arrows. So always nucleophile attacks on the electrophile. So that's the basic chemistry. So nitrogen being an electrophile, it attacks on the nitrogen being the nucleophile, it attacks on the electrophile, and as a result you generate a carbon nitrogen bond, and water can act as an acid as well as it can act as a base. So water is acting as a base in this case, picks the proton, and this water becomes hydronium ion and the nitrogen becomes neutral. And in the next step oxygen picks this proton and the water becomes this hydronium ion becomes water, and this oxygen gets protonated and OH2 is a good leaving group. Now the lone pair of this nitrogen reverts back and this water leaves as a leaving group. Now this is first step, amine formation. What happens in the next step, we generate enol. So we have this ketone cyclohexanone, we are reacting this cyclohexanone in acidic catalyzed mechanism. What happens is we generate enol formation, and the lone pair of oxygen reverts back and makes a double bond between carbon, and this double bond attacks on this carbon, this one, and this double bond shifts towards this nitrogen, and this is a reversible arrow, you get this one. Now in the next step this nitrogen picks this proton from oxygen and oxygen becomes neutral, in this case it's positive. Now in the last step this OH negative picks this proton from nitrogen and you get beta amino ketone. Okay, this was different way of explaining the same mechanism of Mannich reaction if needed. Okay, this is the list of other examples of Mannich reaction. So this is a cyclohexanone, formaldehyde, and again this is secondary amine HCl. Now you look towards the product, cyclohexanone remains same, the formaldehyde is converted into one carbon, that is CH2, and this CH2 makes bond with this nitrogen, and the hydrogen of this nitrogen is lost, this one. So this is how you can write the product of Mannich reaction. So this 5-membered ketone remains same, formaldehyde is converted into CH2, which is this one, red one, and the secondary amine loses its hydrogen, the rest is same. Look at the next example. You have acetone, you have formaldehyde, you have piperidine. Piperidine is a secondary amine, so it could be any amine, and this is HCl. Now you have the same ketone, acetone, same black line, this formaldehyde is converted into CH2, that's the one, and this one. Now you have a bond between this amine with formaldehyde carbon, this one, and the amine loses its hydrogen. This piperidine loses its hydrogen. That's it. So this is how you can write down the product from the starting material. Okay, this was about Mannich reaction examples. This is another example of Mannich reaction. You have a cyclohexanone. This is a secondary amine. This one is acetaldehyde. Acid catalyzed, you get this product. How you can use this Mannich reaction in retrosynthesis? For example, this is a compound, so you do O alkylation first, then do reductive chlorination, you get this. Now if you look at this part, this is a Mannich reaction because this is ketone, this is beta amino product. So you disconnect from this one in this way and you get starting material, this acetophenone, secondary amine, and formaldehyde. This is how you can use Mannich reaction to prepare drugs. This is fluoxetine is a drug which can be prepared by using Mannich reaction. So Mannich reaction has a wide variety of applications in organic synthesis. It's the last slide. These are the applications of Mannich reaction. It is used in the synthesis of many medicinal compounds such as tramadol reaction, and number 2 is it is used in the synthesis of other organic compounds such as peptides, nucleotides, antibiotics, troponinone. It is used in the production of agrochemicals, plant growth regulators. It is used in many reactions in polymer chemistry. It is used in synthesized alkyl amines. It is used in converting nonpolar hydrocarbons and detergents and soaps. It is used in production of many cleaning materials, chemicals, epoxy coatings, automotive fuels, treatments, etc. So these are the applications of Mannich reaction, and that's it about Mannich reaction. If you are unclear about any slide, any particular thing, please drop your comments in this video. And thanks for watching. Take care. Bye.